Hi students, welcome to Alpha C learning program Mathematics. Now yesterday actually in previous session we have done a problem basing on ends of lattice rectum. When ends of lattice rectum is given, then what about here the equation of parabola? And we observed actually while discussing about concepts we have observed through ends of lattice rectum maximum two parabolas can be drawn. Okay, so here this is one parabola and this one is the other parabola we have observed. Then what is the data given? Actually the ends given as -3, 2, -3, 1. So in previous session we have done one method and other method also there to solve the same problem. What is the other method? Whatever already one method we have done, that method is useful for any kind of parabola, oblique or any kind of parabola, whereas this method is useful whenever axis is either parallel to x-axis or y-axis. Okay. Now first of all our observation is L and L dash given. One is here -3, 2, the other is -3, 1, and we know that the middle point of lattice rectum is always focus. Moreover, it lies always on axis of parabola. Okay, so the middle point, if I take here, the middle point is nothing but -3, 3/2, which is exactly focus. Okay, this is only for lattice rectum, not for double ordinate. This is here double ordinate as well as passing through focus, and here therefore the middle point is exactly focus. And now students, once it is the focus -3, 3/2, and we observed here abscissa is same, therefore the lattice rectum is parallel to here exactly which one? Y-axis. As it is parallel to y-axis, therefore we can observe here these are vertices actually for this one and for this one, and this vertex comma focus, the line joining vertex comma focus, always here those are on x-axis of parabola. And now here you observe this is -3, 3/2 implies as this point also exactly on axis, therefore we can take here the ordinate of this point also here 3/2. What is the reason behind it? Because this one is acting as exactly parallel to here y-axis, therefore as this is 3/2, therefore here also you can take 3/2, and for a dash for the other parabola also the ordinate value you can take as here 3/2. Okay, so the ordinate value you can take 3/2 here and 3/2. Then what is the leftover value? Alpha. That means we require abscissa of our vertex. So abscissa of our vertex is alpha. Now how to find this alpha value? If it is any kind of parabola, then we use here, take these points, substitute in curve equation, and thereby we can obtain. But here this is directly axis is parallel to y-axis, therefore make use of that one. And you know here LL dash value equal to how much? It is nothing but 4a. Understand? It is 4a, and that 4a in this problem it is nothing but 1 unit. And hence a value is how much here? It is 1/4. As a is 1/4, and we know that as equal to always it is 1/4. That means here a. That means here distance between focus and vertex is always we are denoting as 1/4 of lattice rectum. That means here it is equal to a, and thereby this value alpha 3/2, it is -3, 3/2 implies mod of alpha plus 3, because that alpha may be here or other value can come this side. So we are writing mod of alpha plus 3, which is nothing but distance between a and s. Now alpha plus 3 value, if it is mod 1/4, then one time we took plus and one time we took minus, thereby alpha value you got these kind of values. Okay, now what about here this side vertex? As here it is -3, okay, as it is -3, therefore we have taken this side -13/4. Okay, and this side is exactly it is more than, that means here it should be -11/4. So students, this is actually the other method of doing the problem, whenever ends of lattice rectum given, at the same time the line joining lattice rectum is either parallel to x-axis or y-axis, directly you can start the problem. Ordinates are same, as equal to a, and thereby you can obtain the total answer. Moreover, students, observe one important good point, that is as a dash, that means these vertices, these are for two parabolas, and now this one is nothing but bisector, that means perpendicular bisector of here LL dash. Okay, so make note that point. Now after doing this one, students, observe here in the same way, suppose a problem is given minus 3 comma 1, 1 comma 1 are end points of here lattice rectum. Okay, so here which one is constant? Here ordinate is constant. When ordinate is constant, the line is always parallel to here x-axis. That means here lattice rectum is exactly parallel to x-axis. That means here LL dash, this lattice rectum is parallel to x-axis because of the reason ordinates are same. Okay. Therefore, this is minus 3 comma 1 and this is 1 comma 1. And what is the focus here? Again, just now like however we have done, the middle point of LL dash is nothing but the focus, and that is nothing but here minus 1 comma 1. And next other observation, just like this problem only, here this is vertex and this is another vertex of the parabola, next parabola. And now what about here? This is here lattice rectum and this is representing axis. Okay, A comma S, they lie always on axis of parabola, and therefore this line is here exactly parallel to which one? Y axis. Therefore abscissa remains the same, minus 1 minus 1. Even here also same thing, minus 1. Okay, now abscissa remains same. Only thing is here you need to find one unknown value, that is k. Now what about here? Total LL dash, length of lattice rectum. The total LL dash is here 4a equal to 4. And just now we have observed AS is nothing but 1/4 of our lattice rectum. Therefore AS is equal to how much here? 1/4 of this value, that is equal to 1. Hence, what about AS here according as from here, that is nothing but mod of k minus 1 is 1. That means this distance between A and S. And thereby you got k minus 1 is 1 and this other value minus 1. So we got k equal to 2 or k equal to how much? 0. Now once you got these values, then what about here? Parabola equation. As axis is here exactly how it is parallel to y axis. As axis is parallel to y axis, therefore our parabola is of the form x minus alpha whole square equal to plus or minus 4a and into y minus beta. Okay, so this is our parabola, upwards or downwards. Now students, observe here, this is minus 1 comma 1. So the values here k is 2, k is 0 you got. Therefore here I have to take exactly this as how much here? 2. So this value I must take, this is 2. And next this value I have to take minus 1 comma, what is the value? 0. Okay, in the order you have to come 2, 1, 0. Okay, in that way if I consider, then what about the values? Now this parabola where a of minus 1 comma 2 alpha beta if I take, this is equal to minus 1 comma 2, then in that case parabola is coming downwards. Downwards means what symbol I have to put now? Minus symbol. That means x plus 1 whole square is equal to 4a, how much we got here? 4. Therefore 4 into, this is how much now I have to write? Minus symbol, because this parabola is coming downwards. So minus value I have to put here, minus 4 into y minus what is the value? 2. Okay, so this is one equation, this is downwards. And what about the other parabola, that is alpha beta? Now I am taking this value as minus 1 comma 0. Okay, now this is the other parabola, so this one we applied for this one. And next another vertex I am taking, that is alpha beta minus 1 0. Now it is upwards. When the parabola is upwards, then what about the equation? The equation is nothing but here x plus 1 whole square. And here 4a means the value is 4 and y minus 0, that means it is y. positive, because the parabola, this is here upwards and this is downwards, so here minus. In this way, this model, when ends points of lattice rectum given, then how to solve problem? The observation is very important. What is the observation here? Whether abscissa are same to these values, or like this here ordinates are same. So students, observe which is exactly minus value, for what vertex it is taking negative value, and for what vertex it is taking here positive value. That is very, very important. Okay. So let us observe this problem, students. Read this one. If angular bisectors of coordinate axis, okay, angular bisectors of coordinate axis cut a parabola, that is our standard form parabola, cut a parabola at the points O comma A comma B, then area of triangle OAB. Okay, this is our question. Just draw diagram. You can draw diagram, that is very easy. Now you know the standard form of parabola curve. So this is our parabola curve OAB. This is our parabola where vertex is here. Usually we denote capital A, but here now I am writing O. Okay, this one is. Now what about here? Angular bisectors. Coordinate axis angular bisectors, all of you know very well, that is y equal to x and the other one is y equal to minus x. Therefore, y equal to x line, if I consider, this is the line y equal to x. So I am taking in this way y equal to x line, and another line is nothing but here like this y equal to minus x. Okay. So these are our angular bisectors. One line is nothing but y equal to x and another line is here y equal to minus x. Now they said here the parabola and these angular bisectors intersect at the point A and B. So this is A and B. Now what is the question here? The question is nothing but what about here? Area of triangle OAB. Okay. So area of triangle OAB they are asking, that means this entire area we require. Okay. Now whenever any point is on the line y equal to x, on the line y equal to x, we observe here abscissa same as ordinate. Therefore, I am taking this point as here k comma k. Okay, and the same point you can observe here y equal to minus x. Let us consider this point as here k comma minus k. Understand? K comma minus k. Only just for easy purpose you can make use of directly k comma minus k instead of using some other ordinate. That means some other value l comma minus l you can consider, because the point is on the line y is minus x, but I am taking same value just to make easy the problem. Okay. And now so this line y equal to x we have taken, and these values here our k is completely unknown value. And what is that unknown value here? This point A is or B is, they are on the parabola y square equal to 4ax. Therefore here A lies on parabola y square is 4ax. Implies, let us observe here, what about k value? K square equal to 4ak. That implies k equal to how much here? 4a. And hence this point is nothing but how much here? 4a comma 4a, and when k is 0, this value 0 comma 0, k get cancelled. So now here this point is 4a comma 4a, and this point we have taken now 4a minus 4a. Okay, so in this way we have taken the points. Now they are asking about what about here? Area of triangle OAB. So OAB means you can observe here this is the base, and this value you can take exactly the height. Okay, or else you can take here OA and this OB. Those are also here at right angle, and OB length, OA length you can obtain, or directly I am taking here this is the base completely and this one is height. So what about this value here? It is 4a comma 0. So now completely the area is delta equal to half base. Base means we are taking AB. That implies what is that value here? It is nothing but 4a plus 4a, that is 8a, and into the this one if you treat as height, then this is into 4a. Therefore finally what is our answer here? 16a square. So like this here, sometimes you can make use of the concept of directly double ordinate. They said here only angular bisectors are cutting the parabola at the points AB, and of course O is there. And now whenever you got in that way, not necessarily K comma K and this is L minus L, if you take also same kind of result, final answer will be the same. So this is area of triangle formed by triangle OAB. Okay, and next another problem, observe students here. The slope of a line, okay, the slope of a line which is belonging to family of these lines, okay, slope of a line which is belonging to family of these lines, and moreover here this family of line slope they are asking, but how is this line? They are telling that here this line actually meeting a parabola, and in that meeting parabola again it should have here a shortest intercept, okay, slope of the line which belonging to the family of these lines and having the shortest intercept, okay, having shortest intercept, okay students. So this one is shortest intercept to the parabola, and that parabola equation also here given, okay, shortest intercept on this parabola, okay, x square equal to 4y minus 4. Then now here first of all you know this concept in our first year, that means family of lines. First let us observe here what about this family of lines. Then we write this one as here x 1 into x plus 1 into y, and this is minus 2. So it is nothing but x plus y minus 2, and after that we write it as lambda times x minus y, and this one is here plus 2 equal to 0. So this one is here L1 plus lambda L2 equal to 0 type. So now the equation is of the form L1 plus lambda L2 is 0, implies this is representing family of lines, and all these lines they are passing through here point of intersection of L1 is 0 comma L2 is 0. So what is here point of intersection of L1 is 0, L2 is 0. If you observe here, if you solve these, y and y get cancelled and you will get here 2x, and this value also equal to 0, implies what about here x value you got 0. When x is 0, what is the y value here 2. Therefore the point of intersection we got here how much? It is 0 comma 2. And whenever you got these type of problem students, as soon as you got any point here, just have a glance whether this point has any relation with the given parabola or not. That is every time very important. This point, is it having any relation? In the sense, is it the vertex of the parabola or focus of the parabola or one of the end points of lattice rectum, like that here we must have just any glance on this one. Okay, now if I observe like this here, this is x square equal to 4 if you take common, y minus 1. Okay, now what is 4a value here? 4a equal to 4 in this problem, that implies a equal to 1. Moreover, what is the vertex in the problem here? The vertex is nothing but 0 comma 1. And how is this parabola actually? The parabola is here vertically upwards. That means this is our parabola having vertex how much here? 0 comma 1. And what is a value here? 1 unit. That means what is the focus here? It is nothing but 0 comma 2. Therefore students, observe clearly whatever the point of intersection you got from all these family of lines, that point is nothing but exactly to this parabola focus. Now this is the important point which we have to observe while solving these model problems. As we have observed exactly that point is focus, therefore let us have a glance on the parabola. So this is the parabola having vertex at 0 comma 1 and focus is nothing but how much here? 0 comma 2. Now what is the question they have asked here? The shortest intercept on this one. Understand? Shortest intercept on this one. That means here through focus many lines can pass. and this only given by here our family of lines equation. So all these lines, whatever the family of lines you have observed, all the lines they are passing through like this. Among them one line is nothing but what here? Latus rectum. Okay, so among all of them one line is exactly latus rectum, and shortest intercept means which is nothing but here latus rectum. So from this family, students, we have got here all family of lines, those are nothing but all focal chords. And among all focal chords, the least one we know it is nothing but latus rectum. Now the question they asked here about slope of that line. Okay, so what is slope of this latus rectum here? 0. So simply you can use here the concept of which one? Latus rectum. Okay. Now let us observe this problem. If a parabola reflector is 20 centimeters in diameter and 5 centimeters deep, then find focus. So it is a parabola reflector. You can observe here, this one is like this. It's a parabola reflector and it is here 20 centimeters diameter. That means this is the diameter and it is 20 centimeters, and next one is 5 centimeters depth. That means in this way it is 5 centimeters depth. Okay, so now you observe, students, this problem simply convert in terms of parabola, where directly the axis you consider as x-axis, and here the directrix and all as usual parallel to y-axis, etc. So as I am taking here the axis as x-axis, therefore 20 centimeters diameter implies this is our diameter, as this one is exactly axis, therefore here this is parallel to x-axis. So take this as 10 and this one as minus 10. And next other one we have taken 5 centimeters deep. That means this one is here exactly 5 centimeters deep. Okay, now that means this is our 5, 0 and this is 0, 0. And exactly at this stage you don't know, it seems to be like a double ordinate. Okay, like a double ordinate, maybe it may be latus rectum also, but at present you can't say. Let us observe what about this value. The question they are asking about here, what is the focus? Okay, now what about here this model parabola? It is exactly a parabola coming in this way, where vertex is 0, 0 and one of the points on these is 5, 10 and the other point 5, minus 10. Okay, students, therefore let us take here parabola is exactly of the form y square equal to 4ax, because it is opening we have taken this side, or you can take same thing to this side also, nothing will happen. Now once this is y square is 4ax, we don't know about here a value. To that purpose let us substitute here one point as 5, 10. Then what about here if I substitute 10 square equal to, it is 4a times into x, that is here 5. Okay, therefore you got here a value how much exactly? 100 divided by 20. So a value is 5, and hence here focus to this parabola, the focus is nothing but how much here? It is 5, 0. So exactly you got this 5, 0 as focus. Hence to this problem, students, the focus is nothing but what? 5, 0. So this you can understand directly. Parabolic reflector you can take in this way, or you can take this side, or you can take upper side. Any side you take accordingly, change here standard equation also. And next problem, observe here the foot of perpendicular drawn from P onto the directrix of a parabola is given as Q. Okay, so observe this problem. If Q is foot of perpendicular from a point P which is on the parabola, how is this parabola here? It is again whose axis is parallel to x-axis. Okay, and what is the vertex of that parabola here? Vertex of parabola is nothing but 3, 0. So this is the parabola, students. Actually this is our 3, 0 and this is our 0, 0. And now here Q given as here foot of perpendicular drawn from P, and this P is a point on the parabola. That means here if you take the point P actually, and from any point on the parabola, and now if this is the directrix, suppose, okay, if this is the directrix, or else let us observe here what is equation of directrix. What is equation of directrix here? The 4a value equal to how much it is? 4a equal to 8. That implies a equal to 2. Okay, so a equal to 2 you got, 4a equal to 8, and thereby equation of directrix or formula is x is equal to how much here? Minus a. And what is x value in this problem? That implies in place of x you are having x minus 3, and that is equal to how much you got? Minus a. That means minus 2. That implies x is equal to how much here? 1. So that here the directrix is nothing but here, exactly here, this is the line x is equal to 1. Now they are telling here a point P on this one. From the point P actually they have taken this is a foot of perpendicular onto this. So this is our q value. Okay, foot of perpendicular onto the directrix, that is q. And next they are telling here the focus, here SB the focus and SPQ is given as here equilateral triangle. Okay, so now here if I take SPQ equilateral triangle, thereby this is our S value. Now SPQ they are telling actually equilateral triangle. Now once SPQ is equilateral triangle, this angle is how much here? 60 degrees, and this angle is 60 degrees, and this one also here how much? 60 degrees. Then what about here this part? Actually this part has to be 30 degrees because they said here it is foot of perpendicular on directrix. Hence this part must be here 30 degrees. And now here SQ is our requirement, or SP or PQ, that is our requirement. Now here again this is 90 degrees because directrix is perpendicular to axis of parabola, 90. So this is 30, 90 implies what about this angle? Actually 60 degrees. Okay. Now students, as this is our requirement, therefore let us observe here in this triangle, right angle triangle, you can observe here the required value. Okay, but here what is the parabola given? Y square equal to 8 into x minus 3. So this is our 3, 0 point, and now the requirement is here SQ. So you can make use of simply here sine 60 degrees. What is sine 60 degrees actually? Sine 60 degrees if I take, it is nothing but, suppose if I take this is D, and then sine 60 is nothing but here QD divided by how much? SQ. Okay. Then what about the interesting here? This is 3, 0, and from here to here you require distance also. So just to find the distance and thereby we can obtain the point. Then how we can get that exact value? Okay. So as this is 60 degrees and this one is 30 degrees, and you know here in parabola SP equal to how much students? It is always PQ. Okay. That's why you got 60 here, 60 here. And now what about this value? Actually that focus is nothing but here actual value how much? A, 0. That means it is 2, 0. But to this how much we need to add here? Extra you have to add alpha beta. That means 3, 0. That implies this is nothing but here 5, 0. So focus is nothing but 5, 0, and this point vertex is here 3, 0, and thereby you can obtain here clearly the other value. Then how to obtain students the other value? The other value is nothing but here I am taking here right angle triangle SDQ. Okay. So right angle triangle SDQ I am taking, and from this right angle triangle SDQ, what about here this value SD? All of you know it is distance from focus to vertex. What is distance from focus to vertex? Actually you know this value SZ. Okay, SZ is nothing but 2a. Okay, so SD is nothing but here 2a, and a value it is 2, therefore this value is nothing but 4. Therefore I am taking here sine 30 degrees. Sine 30 degrees is nothing but here SD divided by what is the value? SQ. Okay, so SD is nothing but 4, this is 1 by 2, and this is 4 by SQ, and hence SQ value how much it is here? Exactly 8. Therefore students here length of the side is nothing but 8 units. Okay. So now observe this problem. If equilateral triangle is inscribed in a parabola, y square is 4ax, whose vertex is at the vertex of parabola, find length of side. or they may give whose one vertex is exactly at the vertex of parabola, find length of the side. So here standard form given students, that means take here y square equal to 4ax. So this is y square equal to 4ax parabola, where one vertex, suppose this is vertex of parabola 0, 0. And next one they said equilateral triangle. So equilateral triangle is inscribed, implies suppose this is our equilateral triangle, it is inscribed where one vertex is exactly at the vertex of parabola. Now take this one as here B and this is here suppose C. Okay. And now one of the points on parabola I want to take here, y square is 4ax. We have parametric values also, but using directly also I can take here, suppose y value, understand students, y value suppose if I am taking k, then what about x value, y square by 4a. That means this value you can take k square divided by 4a. In this way we can consider here one of the points. Then what about this point, as it is equilateral triangle, therefore here it is exactly the middle point. Okay. Moreover it is perpendicular also. Therefore this point is nothing but k square by 4a and this value is minus k. And this one you can write as k square by 4a comma 0 also. And next it is equilateral, so 60 degrees here, 60 degrees here, and this is bisecting angle also. Therefore this one you take here 30 degrees, right? And once this is 30 degrees, what is the requirement here? Length of the side. That means you find either AB or AC, any of the values. Then how to obtain this one? If I find here tan 30 degrees, okay? Tan 30 degrees if I write, what is tan 30 degrees? Suppose it is D, from right angle triangle ABD, the tan 30 degrees. Now this is equal to, exactly this is how much length actually? This is our k value, okay? From here to here k. Therefore k divided by k square by 4a. So this is k divided by k square divided by 4a. Okay. So now this is our value, tan 30 degrees I have taken. So it is k and this part is k square by 4a. And this is actually 1 divided by root 3 equal to 4a and divided by what is the value? K. And hence k value, how much we got here? 4a root 3. Okay. That means here this k value is 4a root 3 you got. Then what about here? They asked you about length of the side. To obtain length of side, now you can make use of simply sine value also. So what is sine 30 degrees here? Sine 30 degrees is nothing but here BD divided by AB. Okay. Or you can use any other concept, but I am using now sine 30 degrees is equal to BD divided by AD. Now what is BD value? It is K. And sine 30 degrees means it is 1 by 2. So 1 by 2 equal to BD. This is our K value. And divided by AB. That is our requirement. Okay. That implies AB equal to, what is the value here? 2K. And next one, K, just now we observed what is the K value? 4a root 3. So 2 into 4a root 3 implies this is nothing but 8a root 3. So in this way you can find here whenever the one of the vertices of equilateral triangle is exactly at the vertex of parabola, thereby you can obtain clearly length of the side of equilateral triangle, how much it is? 8a root 3. So one time we have taken sine and another time we have taken the tan value. Okay.